Hello everyone. Today we're going to be graphing compound inequalities. Now the first thing is, what is a compound inequality? So let's go back to what we already know, which is, what is a simple inequality? A simple inequality is just anything like x greater than 3. That is a simple inequality. So a compound inequality, what is that going to be? So a compound inequality is made up of two inequalities. So when you have more than one, and you join them using the words and or the word or. So that's a compound. It's a combination of two simple inequalities. So for example, they look something like this, like x less than 4, and then the word or in between, x greater than or equal to 9. So that would be a compound inequality. Here's another example, x greater than 4 and x less than, let's go, 10. So these are two examples of compound inequalities, condition being they're joined by the word or they're connected by the word and, or the other option would be the word or. So let's look at what the difference is. So it's very important to have the difference between the two straight, because when it comes to graphing, they end up being slightly different in the final solution. So the ones with the word or represent a union of the graphs. So it's just a combination of the graphs. So we put the two graphs together, and anything that gets highlighted is part of the final answer. So it comes down to a number is a solution, or something is highlighted in the number line, because that makes it a solution, if the solution is true in at least one of the inequalities. So if it's highlighted for one of them, it's a solution for the whole compound inequality. Versus the and inequalities, which are different, and represents that both of them have to be true. So it's a combination, an intersection of the inequalities. So pretty much it comes down to the solution has to be true for both of them. So it's where they're both true. So here, first one is 1 is true, where the bottom one is they're both true. Meaning, or means wherever you highlight it, that's an answer, as long as one of them highlights that area, versus and is where they're both being highlighted. To make things a little easier, today we're just going to focus on the or ones. Those are a little easier to graph, so we're going to focus on those first, and then tomorrow we'll look at the ones that have and. So let's go ahead and get started. We have 4 examples to graph. So let's look at example number 1. So remember, the or inequalities are where one is true or the other is true, or where they're both true. As long as one of them highlights that region, we're good. So let's go ahead and start graphing these. First one, so let's look at our first one here. We're going to go ahead and graph x less than or equal to -2. So we're going to go ahead and graph that. So at -2, we're going to put a closed circle, and less than means to the left. So this is my part of my solution. Again, it's a combination, remember it's a combo, of the two graphs. So it doesn't matter if they overlap or not. So the other one's x greater than 1. So here we're going to put at 1, we're going to put an open circle, and then we're going to graph to the right because that is greater than. So these two inequalities individually, you put them together, one to the left, one to the right. These represent all my solutions. So sample solutions would be like -5, -4, let's say 4, 5, 6, 7. These are all solutions because they exist in this area and in this area. So these are just sample solutions. So let's write down some solutions. Let's just so you can have it on your notes. So some possible solutions. I'm going to write down 3. So I'm going to pick one from this area. So I'm going to pick -4. That's one solution. I can pick some solutions from this area as well. I can say 3 is a solution. I can say 5 is a solution. And then there's many, many more. Obviously, we can't write them all out because that would take forever. And it would never be done. So again, this is my traditional compound inequality, the graph for an OR. But sometimes this doesn't happen, one to the left, one to the right. Sometimes they'll overlap and we'll get different types of answers. So that's what we're going to see on numbers 2 and 3. So let's look at number 2. We're going to start at 3. And that's going to be x greater than 3. So at 3, I'm going to put my open circle. And it says greater than 3, so I'm going to go to the right. So these are all my solutions here. 4, 5, 6, 7, 8, 9, 10. Second one, we have -1, which is here. That's also an open circle, and it says x greater than -1. So it's going to be everything to the right. Notice that this one's going to go over that 3 that was open. So this 3 that I'm talking about right here. It's going over that 3, and it's highlighting now. So just go back to ahead. As I go to the right here, I'm highlighting the 0, the 1, the 2, and then it goes over the 3, and it just goes over what I've already had. So in this case, my solutions are something like 0, 1, 2, and everything to the right of it, right? So I have a whole bunch of solutions. So this ends up being a simple inequality. So this can actually just become x greater than -1 because the second one here overlaps the first one. So this compound inequality actually graphs as a simple inequality. All right, so let's go ahead and do the next one. Let's look at another special case, 4. We're going to go ahead and put our open circle. It's x less than 4. So we're going to highlight to the left. So everything to the left. So -1 is the solution, 0 is the solution, 1 is the solution, and so on. A whole bunch of solutions to the left of 4. Now for the second one, we have at -1. We're going to put an open circle. But that spot is already highlighted, so it's technically a closed circle. And this says greater than 1, -1. So this means we're going to highlight to the right. So it's covering my closed circle, and it highlights to the right. So everything got shaded here. So here, everything is a solution. So here, all numbers are solution because the entire number line got shaded. So here we have our solutions being all real numbers. So all numbers are solutions. 2.7, whatever you want to name, it's a solution. So again, this is another special case of a compound inequality. So let's go ahead and look at our last example. Notice that our last example, it is not solved for x. So we need to go ahead and solve these for x ourselves. So in this first one, it's a two-step equation. We're going to move that 10 over by adding it on both sides. And then we're going to divide by 6. So we're going to add 10, -6x greater than -30. Divide by -6, divide by -6. So x, be careful here because we divided by a negative, our inequality switches. When you divide by a negative, your inequality definitely switches. So we're going to get 5 here. Now let's go ahead and do our other one, which is the one on the right. We're going to subtract 7 to both sides. So 10x less than -30. We're going to divide by 10. So here we have x. Here our inequality does not switch because we are not dividing by a negative. So we get -3. So let's go ahead and graph this. Remember, it's the combination of the two simple inequalities that make the graph for this compound inequality. So let's go ahead and go to 5. Put an open circle at 5. This is a less than, so we're going to go straight to the left. So everything to the left. So -4, -3, -2, -1, 1, 2, 3, 4 are all solutions. Now for the second one at -3, I'm going to put my closed circle. It doesn't really matter because it's already been highlighted, but technically it's a closed circle there. And then this is less than -3, which highlights something that was already highlighted. So we're just highlighting more of the same thing. So in this case, my answer is everything to the left of 5. So my solutions, let's do some sample solutions, right? Would be something like -4, 0, 1, 3, and so on. There's a whole bunch of solutions. But this is really just a simple inequality at the end of the day. It's just x less than 5. Everything to the left of 5 is my solution here. So that's the general idea. With the OR inequality is whatever gets highlighted is a solution. If you highlight over an open circle, that open circle becomes a solution. Now, going back to the general idea, the traditional or looks like this. If there's no overlapping, your final answer should look like this. Otherwise, if they overlap, you'll have something different than this. So overall, if it looks like this is automatically an or, if your graph looks like that. All right, go ahead and start your practice, and good luck.